Welcome to Pomodoro Joe for Wednesday, February 1st, 2023. Today we're looking at LeetCode problem 1071, greatest common divisor of strings. This is an easy problem. The problem statement says, for two strings s and t, we say that t divides s if and only if s is equal to t plus some number of t's, i.e. t is concatenated with itself one or more times. Given two strings, string 1 and string 2, return the largest string x such that x divides both string 1 and string 2. And then they give some examples. So you have ABC, ABC, and ABC, and the common divisor is just ABC. For example 2, you have AB, 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 and string 2 is just AB, AB. Their common divisor is the element AB. And finally, the last example, you have leet and code, and there is no common divisor, or the common divisor is the empty string, so they return the empty string. I will try to break this down into multiple pieces. We'll do the straightforward implementation first, and then we will try to refine until we get to a better solution each time. So with that, we'll set 25 minutes on the Pomodoro timer and get started. Okay, so the way I approach this problem is similar to the way I approach other recursive problems. I want to break this problem down into smaller pieces. The first thing I look for is something called the base case. So what's my simplest case here? Well, that's if string 1 is equal to string 2. Then we can just return. That is the greatest common divisor. We'll just return string 1, but you could return string 2. They're the same. Okay, what's the next case? Well, that's a little bit harder to think about, but I'll go to our example here. Our next case is, well, what if we have two strings of the same length, but they're not the same string? Well, then we know that there is no common divisor, or the common divisor is the empty string. So the next thing I'll do is look for the lengths. So I'll get length of string 1. Now, if these lengths are the same, but the strings are not the same, then we know we can return the empty string. So if L1 is equal to L2, we're just going to return the empty string because we've already checked if they're the same. Now, if they're not the same string, but they are the same length, we have to return an empty string. Now we get to the recursive part. How do we break this problem down into smaller problems? So the thing to notice here is that for two strings of different lengths, you have one string longer than the other string, which means that that longer string has the other string embedded in it. You can think of this longer string as the shorter string plus some number of elements of the greatest common divisor. So what we really want to do is say, let's just subtract the smaller string from the larger string, and whatever is left over, that has to be made up of more of these elements that we're looking for, this X string. So let's start there. Let's break this down into, let's get this remainder string, we'll call it. All right, so if string 1 is greater than string 2, or the length of string 1 is greater than the length of string 2, then we have this new remainder string. And that's going to be just string 1 from the end of, I guess, the length of string 2 to the end. So we'll say L2 to the end. So essentially this is just saying, let's remove the beginning piece of string 1, and that beginning piece is the same as string 2. And whatever's left over, that's our remainder string. So how does this help us? Well, we know that remainder string also has to be made up of these elements. So we can call a recursive call on our GCD of strings, passing in this remainder string. So now we have a result. So let's see. I'll start out with some result up here. And we'll set it equal to the empty string to begin with. So now our result can be equal to, and we have to call self on GCD of strings. So now we've broken the problem down into smaller inputs, and this time we'll pass in, let's see, what do we pass in? Well, we've just broken down string 1, so we'll still pass in string 2, and then we'll pass in our remainder string. Okay, so that's our recursive call. Now, let's move down and do the same thing if string 2 is greater in length than string 1. So essentially, we just flip all these over. Okay, so now I've handled the two cases where string 1 is longer than string 2, or string 2 is longer than string 1, and we're breaking down the problem into smaller pieces each time we make this recursive call. So these strings are getting shorter and shorter and shorter. Eventually, they will either be the same string, or they will not match and will return the empty string. All right, so now that we have our result, let's just do some double checking. So let's see, I'll call the result length L3. So that's going to be the length of our result. And so our result is going to be this element that we can build up string 1 and string 2. And so there's some number of result elements that we need to build up string 1 and string 2. Well, so that's going to be some multiplier. So we'll call this the multiplier for string 1. And that's going to be equal to the length of string 1 divided by the length of our result. And then we can just double check here. So if our result times M1 is equal to string 1, then we're good. So we'll actually just double check. We'll just say that if it's not equal to string 1, then we'll return the empty string. So again, this is just double checking. So we're going to build up a new string out of our base element result and make sure that it matches our string 1 and string 2. And if all those checks pass, then we'll return our result. Okay, I think this is pretty good. Let's give this a shot and see how we do. I did not check for modulo 0. Okay, divide by zeros are definitely a problem. If the length of our result is 0, so if L3 is equal to 0, then we will return the empty string. Yeah, I don't want to be dividing by 0. That's bad. Let's try that again. Okay, and we pass, and we actually do a pretty decent job. This beats 98.96% of other algorithms for runtime, and it beats 70% for memory. That's not bad at all. All right, let's jump back and see if we can make some refinements to this. So one simple trick we can do is, instead of doing all these checks here at the end, we can check simply at the beginning, can these strings be made from one base element? One way to do that is to say, well, if string 1 concatenated with string 2, if it's not equal to string 2 concatenated with string 1, see, I reversed the order of those. So if concatenating string 1 to string 2 is not the same as concatenating string 2 to string 1, then we know we have some elements in there that are not made up of our base element. So we'll have to return an empty string. Now that we have that, we can get rid of all of these checks down at the bottom here. We don't need to do this anymore. We don't have to do that divide by 0 check. We don't have to do any of these other checks. We're checking at the top, can these strings be made up of some base element? So let's give that a shot. All right, then we'll submit that, see if we do any better. We actually do a little bit worse. So in terms of our memory, it's the same, but our runtime drops significantly. So that actually doesn't help all that much. I think because we're concatenating strings, it's not cheap. I'm a little bit curious. Can we get rid of this altogether? Do we even need this? Let's try that. Yes, so we do need that. All right, it's worth a shot. Okay, so what else can we do here? Well, this really is a math problem. It really is a GCD problem. You're trying to find the length of the element that is the greatest common divisor of the lengths of string 1 and string 2. We're doing that here by actually breaking the string down into pieces, but you could do this purely mathematically. So how do we do that? Let's create our GCD function. All right, so down here I'm going to create a GCD function. And it's going to take A and B. So those are going to be the lengths of our two strings. To find the greatest common divisor of two numbers, you say, if A is equal to 0, then the greatest common divisor is B, so we'll return B. And if B is equal to 0, then the greatest common divisor is A. If they're both non-zero, then we have to find out which one is larger. So let's see. If A is greater than B, then our remainder is going to be our A mod our B. And now we need to call GCD on our remainder and our B. Okay, and if A is not greater than B, then that means that A is greater than, or B is greater than or equal to A, so we can do the opposite. So all this is doing is finding the greatest common divisor mathematically of two numbers A and B. And we're basically doing the same thing with our strings. We're finding the greatest common divisor of two strings by breaking the strings down into pieces. That's exactly what this is doing mathematically. So what we'll be doing here is essentially finding the length of our remainder string, our greatest common divisor string. So we don't need this if L1, L2. We can get rid of this. This is going to be replaced by saying our L3, the length of our greatest common divisor, is going to be the greatest common divisor of L1 and L2. And then our result, let's do a double check. So if L3 is 0, that means there is no greatest common divisor. We'll return an empty string. Otherwise, our result is going to be equal to, it doesn't really matter, string 1 or string 2, up to our L3. So that's basically saying L3 is the length of our greatest common divisor string. So we're just going to make a greatest common divisor string out of grabbing the first L3 elements out of string 1 or string 2, it doesn't really matter. And then we'll return that result. Okay, let's give that a shot. All right, and we'll submit that, see if we get any gain. Not really, we drop. We get 75% and 23% from memory. So not too great. We'll do one last thing. So this GCD that we just built, Python provides this for us. We're really lucky with Python. So instead of calling our own GCD, we can call the math library GCD. Now we'll submit that. And we beat 95.7% for a runtime and 70% for memory. So that's actually a pretty decent solution. All right, so let's take a look at our working solutions here. We had the first one, which was 98% recursive solution. The second one was an 81% with 70% memory. Let's see, I didn't look at the memory. Yeah, 70% memory for the first, 70% memory for the second with 81% runtime, 75% runtime with 23% memory, and 95 and 70. So it turns out our first solution was actually our best performing solution. All right, I'll leave it there. I'm out of time. Check out the description for links to code on GitHub. You can also check out this problem on your own. Go to LeetCode.com. Check out 1071, greatest common divisor strings. All right, hope you enjoyed this. Hope you had fun. Hope you learned something. Hope you can go out and write better code.